we go to something called as system architecture. Okay, system architecture. So what do you think is a system architecture? So I put some picture here as a reference for you. What do you think is a system architecture? Okay, someone has a question on spec definition. So the question is, someone is asking, is the spec definition is provided by customer? No, spec definition is not provided by customer because the customers may not be, technical people, right? Let's say I am a user of a mobile phone. So I probably don't know anything about mobile phone technically. So I cannot give a spec definition, but I can tell if somebody is doing a survey asking what do I want in a mobile phone, maybe I'll say I want this kind of camera, this kind of display and all that. Okay, so that's where product definition comes into picture, and you take that and someone within the company who's designing this phone, who is technical expert, comes up with a spec definition. Then someone is asking, is there a specific way to read specifications? Yes, good question. So specification documents are very long, like 100 pages, 200 pages. So if you ask me, okay, should I start from page 1 and go till page 200? Not really necessary. So once you start working, you will know that I'm looking into a particular block of this product. So you will read only that section of that particular table, which may be few pages. You don't have to really go through the entire document. Okay, so the question is, what is system architecture? So I got an answer saying it's a basic block diagram of a system. Yeah, that is actually correct. So here what I've done is, let's say you're thinking of a mobile phone, and let's say it has various blocks. So it has a display, it has a camera, it has a radio, it has a processor, and it has many more other functions. Okay, let's say I put it into different blocks and I call it as a mobile phone. Now what happens is, now there is a team. Okay, it's not a single person, but there is a team which looks at these various blocks. So what they do is they say that, okay, these are the various blocks in a mobile system, and these different systems or subsystems together form a bigger system, which is a mobile phone. Okay, and like how I said before, if you are working on a bigger system like this, obviously there is no one person who has expertise in all these subsystems. So these are different teams which work together and come up with a system architecture. Okay, so system architecture, someone already said it's a block diagram, but a detailed one. Okay, it's a detailed block diagram of a system. Say you are working on a particular block, and there is another team in your company which works on a different block. Let's say you are a display expert, and then there is another team which is working on peripherals like this, like ports, like USB ports, or let's say mouse or keyboard or something. So what happens is, you have to work together with those teams because you have to design a total system, right? That's how these different blocks are also interacting with each other to come up with the system architecture. Now I have taken a picture here, so you can see that this is a detailed block diagram. This is a system architecture. So I want you to guess, what does this system architecture represent? Just take a guess. What could be this system architecture? I picked this picture from internet. Okay, someone said PC. Yes, correct, it's a computer. But which computer? Can you guess? Notebook or laptop? Microcontroller. So this is a very old one. Okay, so I'll give the answer. So this is the earliest Apple's Mac computer. I'll give you the reference here. So if you go to this website that I've given here below, you'll find this picture. So this is a MacBook, earliest one, and this is how their system architecture was. Okay, now next stage. Let's say you have done the block diagram. Okay, so what we covered so far, we started with product definition, and then we said, okay, we'll do the specifications. So now we have a system architecture, which is based on the specifications. I come up with this architecture. So I've done a detailed block diagram. So once that is done, what do we do next? At a high level, you start with pen and paper. Okay, you've drawn that block diagram. Then what you do next is modeling and simulations. So in case of modeling, you build a virtual system which represents actual hardware and software. Okay, so at this stage of your hardware design, you don't have a real hardware yet. and you don't have a real software also. So what you do is you build a virtual system. So nowadays there are a lot of powerful software tools. So you build a hardware model there, you build a software model, then you say that, okay, this is my system. From pen and paper, I have done it on a computer. Okay, so it can be very complex system. So you can't really draw everything on pen and paper nowadays. So that's why you need a powerful software tool. And other thing is, if you just draw it on pen and paper, you can't really explain it to other teams. Like how I showed you in the earlier slides, you have to work with multiple teams. It's a multidisciplinary subject. So you need to draw it in such a way, you use a common tool, let's say across your company, and you are able to draw it in a way where you should be able to explain it to the other team about what your system does. Okay, so that's why also it is important to put in a proper model. Okay, once you've done the modeling, what you do is you create some test cases, right? You are saying that, okay, this is my model, this is my system architecture, I have modeled it in a certain way. Now I want to test it. I want to know whether my system works, right? Because it was only on pen and paper. So then I create some test cases. So once the test cases are created, what we do is we test the design or we test the model. So this is called a simulation. Okay, it is still called simulation because you are simulating the system. You don't have really a system or a hardware or software in your hand. You're still just testing your model. You're testing your architecture. Now, once you do this, let's say you find some issues. What you do is you fix them in the architecture. So you have come all the way till here. Now you know that I've done the architecture, but some things are not coming out as expected. So what you do, you go back, look at your architecture, and you fix it. And thus it is an iterative process. Okay, so I've given an example here. So this is modeling and simulation of a wireless system. So I come from wireless background, so that's why all my examples will be related to 5G and wireless and all that. But if somebody comes from a different background, they'll give you a different example of how they model a system. So if you see here, this is an example of a wireless communication system. So this applies to any common wireless system, like here it's written, see, 5G or 4G or Wi-Fi or any other wireless system that you want to design, Bluetooth or whatever you want to design. Okay, system architecture should be very accurate. So it's very important that before you get into modeling and simulation, ensure that you are very sure about your system architecture. Because if the system architecture is not accurate, then your modeling and simulation will take a lot of time, because there will be so many issues and you will see a lot of data, a lot of results which does not match with your expectation. And if you ignore all this and if you start building your hardware, then as I told you, you will do some costly mistakes building the hardware. Then you lose a lot of money, a lot of time. You may also lose your product to your competition, right? You're competing with another competitor, and that competitor may release the product before you plan to release your product. So you don't want to get into all these issues. So ensure that your system architecture is as accurate as possible. Okay, so this requires that you work with various teams, get the accurate system architecture. So in this particular example, so if you see, this wireless system is modeled using MATLAB and Simulink. So these are very popular tools used in this industry. So let me pause for a few minutes and let's see if I have any questions here. Okay, someone is asking me, making technical specification documents is dependent on hardware know-how. How to learn this knowledge? Yes, correct. That is true. So to know technical specifications, you need to know what kind of hardware you're designing. So that comes mainly with experience. So once you're working with someone, you will also know. You can also learn by looking at some documents existing. So if you're going to a company, I'm sure they'll have some documents of existing products. So you can always look at that and understand, okay, what is the design methodology that they're following. Okay, then you'll slowly start learning about it. Please subscribe to our channel by clicking on the subscribe button below to get regular updates of video releases.